Okay, so with nomenclature, it's very important to recognize that we have different categories of compounds. And so we need to recognize those. We have ionic compounds. That's really big. Okay, ionic compounds, the key here contains a metal. So you look at the formula or you look at the name of the compound, and the first thing you do before you can write the formula or the name, whichever one they're asking you for, is you have to identify what kind of a compound it is. And that was on that worksheet. You had to choose I, A, or C. So if the first element is a metal, bang, it's ionic. Done. Okay, what if it starts with NH4? NH4 plus is a polyatomic ion called ammonium. It's an ion. It doesn't have a metal in it though. So there are compounds that are ionic that do not contain metals. But if it starts with NH4, it will be a metal. So there can be ammonium chloride, ammonium nitrate, ammonium sulfate, all kinds of different things that start with NH4. That's the only exception to it has a metal in it. Okay, so those are the ionic compounds, how to recognize them. Then we have acids. Acids start with hydrogen. Their formulas start with hydrogen. Start with H. That was missing. And from their name, the name includes the word acid. So those are pretty easy to recognize. So nitric acid, is it ionic? No, it's an acid. It says so in the name. Okay. And then the other category, which I believe your book called molecular compounds, right? I need to adjust that worksheet. And then we have the molecular compounds. The molecular compounds contain two nonmetals. Two, not three, two. Okay, so that's recognizing what type of a compound you have. Any questions about those? So let's, which one do you want to talk about first? Let's do the molecular one first because it's the easy one. So molecular compounds. This is where we get to use the prefixes. So that's the mono, di, tri, etc. And you use the prefix to tell how many of each of those you have. The prefix goes before the element name. That's why it's a prefix. It's fixed before the element name. To tell how many we have. Don't use mono on the first one. So don't use mono on the first element. But we do use it on the second one, for the most part. Yeah. That's good. I lost the whole thing, I think. Okay, the element name, the second element name changes its ending to "ide." Second element changes ending. Oh, that's way too big. To IDE. Just like the ionic compounds did. The nonmetals, chlorine became chloride, fluorine became fluoride. Okay, in the molecular compounds, it's not an ion, but we change the ending of the name. Remember I used the analogy that the metals are masculine, metal men, starts with M. The nonmetals then are feminine. And when you get a man and a woman together and they get married, traditionally the woman changes her name. And so in these compounds, that's not why they do this, but it's how you can help you remember it, the nonmetal changes its name. It's the one that's last. The last one changes its name. So we get the ending change to "ide." Going the other way around, because you need to know how to write a formula if I give you the name, and you need to know how to write a name if I give you the formula. So going the other way around, you recognize these because they have those prefixes in them. So let's do some examples. Dinitrogen monoxide. So I give you the name, then we write the formula. Well, we look at that first element. It's nitrogen, that's a nonmetal. And monoxide, oxygen, is a nonmetal. And then we have those prefixes di and mono, and so we should recognize this as a molecular compound. And the prefixes tell us how many of each atom. We need the prefixes because there's no ionic charges to help us figure it out. So the first element is nitrogen. So we write its symbol, capital N. Di means 2, so there's 2 nitrogens. The 2 comes after. Monoxide, oxide is oxygen, and it's mono, meaning 1, and so the formula is N2O. I'm just going to make something up. P3F5. Pretty sure that doesn't exist, but we could still name it. You look at that and you see phosphorus, and you find phosphorus in the periodic table. It's a nonmetal. Fluorine's a nonmetal. Bingo, we have molecular compound. So then we're going to use the prefixes. The prefix for 3 is tri, and so we put tri in front of the first element's name, triphosphorus. What is the prefix for penta? What's the never mind. It's penta. Oh, good grief. It's going to be a long day. 5 is penta, and that element is fluorine. But we have to change the ending of its name to fluoride. So penta, fluoride. And remember, there's no flower in fluorine. Okay, see the flower? There's no flour in fluorine. This is a low-carb element, okay? Gluten-free. Question?
So how do you know if you change it to I
Or ite or ate?
Yeah.
Okay, here we have just single elements without any oxygen. So just like if we had this as an ion, if we were going to do the fluorine ion, that would be fluoride. The T's come in when you get oxyanions. So Cl minus is chloride. ClO2 minus is chlorite. And those T's and D's are confusing. I understand that. The T almost always means that there's oxygen present. So if there's not oxygen there, then go with the D. There's got to be some mnemonic or correlation or something to help you remember that. I just haven't come up with that one yet. But if there's no oxygen, you use the T, the D. If there's no oxygen, you use the D. If there's oxygen, it's a T. Any other questions? So let's talk about the ionic compounds. Because we really have to have a grasp of the ionic compounds before we can deal with acids. So ionic compounds always have two ions. A positive one, a cation, and a negative one. There's not 3 or 4, okay? So when you have an ionic compound that you recognize, because it begins with a metal or with NH4, you're dividing it into 2 pieces only. And you name the first piece, and then you name the second piece. And what I see happening is people try to use the prefixes and just go through, and if you've got 3 or 4 elements, you're going to name each element separately, and that's not how it works. You've got a cation and an anion. So let's talk about the cations first, those metals. So we've got metals, and they form cations, positive ions. There's 2 kinds. There's what your book calls type 2, and there's type 1. Type 1, these are groups 1A, 2A, 3A. I just did not plan this out well at all. Can you tell this is spontaneous? And then we've got zinc and silver. Those do not use a Roman numeral. Type 1 forms 1 ion only. Type 2 is everything else. Everything else. All the other metals. And they need Roman numerals. They need Roman numerals because they form 2 or more ions. Ions with different charges. And we cannot predict their charge from the periodic table. The type 1 do not need Roman numerals because we can predict what their charge is. Group 1 has +1. Group 2 has +2. Group 3 has +3. And then zinc and silver we memorize. If it's not one of those, then you need a Roman numeral. Any questions about that? Let's talk about the anions. Monatomic anions. What does mono mean? 1. So monatomic anions have 1 element. These have 1 element. These are going to be nonmetals. And we name them by changing their ending to "ide." Change ending to "ide." So bromine becomes bromide. Phosphorus becomes phosphide. And then the charge comes from the periodic table. For the charge, I think the easiest thing for you to remember is to count backwards. from the right side of the table. From the noble gases. So if we look at sulfur, pretend you're playing a board game and you put your marker on argon. And how do you get to sulfur? You go back -1 to chlorine, -2 to sulfur. So sulfur forms a 2- ion, and its name is sulfide. What charge is chlorine going to have? -1, because it's 1 square over from the end of the periodic table. And its name is chloride. And don't forget that H in there. Okay, so they've got "ide." Just like the molecular compounds did. They end in IDE. Okay? Any questions about these guys? So this is predictable from the periodic table. And then we have the polyatomic ions. These involve memorization. And, I know that you don't like that, but there's just no way around it. Polyatomic, more than one atom. There's only one positive one. We talked about him already. Ammonium is NH4+. All the rest are negative. There's a couple of odd ones. Cn- is cyanide. And hydroxide is OH-. That's a very common one. That one's really important to learn. Hydroxide. So those are a couple that are a little bit weird because they're not oxyanions. You're like, but hydroxide has an oxygen in it. Well, yeah, but it's not considered an oxyanion. And then these guys, those guys have that "ide" ending, don't they? And then we have the oxyanions. There's a whole big family of these. There's maybe a couple of other odd anions there that I'm forgetting, but then we've got this whole big family. So like we have SO4 2-, and we have SO3 2-. And SO4 2- is sulfate. And SO3 2- is the light version. It's got one less oxygen, and it is sulfite. And then we have things like ClO3- is chlorate. Oops, I spelled it wrong. Chlorate. So the 8 does not tell you the number of oxygens or the charge. The 8 is the one that you memorize as the reference point. So you just memorize that sulfate is SO4 2-. And how you go about doing that is up to you. I highly recommend flashcards. You just have to memorize it. Ite is the light version, SO3 2-. Same charge, one less oxygen. But then chlorate, it ends with that same ATE, but it's ClO3 with a -1 charge. Chlorine and sulfur are not in the same family in the periodic table, the same column. They don't act the same. Okay? Chlorine and bromine are in the same family, and they act the same. They form the same type of ion. So bromate has that same pattern of the element O3- charge. Chlorate, bromate, iodate does the same thing. And so there's a bunch of those 8s that you just have to memorize. And then we talked about how And there's probably not enough room over there. Let's talk about the hydrogen, guys. So what if you take HSO4 minus? So you can think of this as being a hydrogen ion plus a sulfate ion. When we put them together, when we combine them, we have to combine their charges. We've got a +1 and a -2, and when we combine those, we get a -1 charge. That's why HSO4 has a -1 charge and not a -2. And for his name, he sometimes goes by bisulfate, but the one I want you to know is hydrogen sulfate. 2 words. Okay, you scared me there. Hydrogen sulfate. So there are a couple of them that do that. Carbonate does that. You can get hydrogen carbonate, and phosphate does that. Hydrogen phosphate. That's not an acid. It starts with H, but that is not an acid because this is an ion. It has a charge on it. Okay? So I could see how that might be a little confusing. Any questions so far? Let's just go over those 8s and ites again. I'm going to use iodine this time. Now I'll draw a little neater. I like the stylus, but it seems to skip a lot, so I've gone back to using my finger. IO3 minus. What's the name of that guy? Look at your notes from the previous. Iodate. Because she's following the pattern of her sisters. ClO 3 minus, BrO 3 minus, IO 3 minus. Okay? Then what would iodite be? It would be IO2. It's the light version. And if we lose even one more oxygen, that's like the extra light, we put a prefix hypo iodite. Because a hypodermic needle goes below your skin. Hypodermis, below skin. Hypoiodite is one less oxygen than iodite. So there's that pattern with these guys. And then if we put one more oxygen on, IO4 minus, that's like the hyper version. Okay, it's got extra oxygen, more than the regular one. And so we don't put in the Y, HY, but it's per iodate. So there's a pattern there. The halogens are the only one that make all 4 that are in that, family there. But there's sulfate and sulfite. There's nitrate and nitrite. Okay? So there's that pattern there. You memorize the 8s, you learn the pattern, and you can make most of those oxyanions. Then there's some weird ones. CrO4 2 minus and Cr2O7 2 minus. Pretty sure I got those right. What did I do? I don't know what happened to those guys. We'll just go on without them. CrO4 2 minus is chromate. Cr2O7 2 minus is dichromate. If anybody has a table of polyatomic ions, double check me on that. Those guys are kind of hard to remember. They don't show up a lot. they don't really fit the pattern, do they? And the dichromate isn't really twice the chromate because the oxygens aren't doubled. So that guy's a little hard to remember. The ones like chromate, dichromate, those guys are less important. Carbonate, nitrate, phosphate, sulfate, chlorate, those guys are very important to remember. So any questions about ionic compounds? Yes?
So are there going to be some that have more than one 8 form, like on those?
Are there some that have more than one 8 form? This one is the only one I can think of. And the name is a little bit different. It's got the di on the front. And this guy's weird also because is chromium a metal? Chromium's a metal. So here we have this polyatomic ion, an anion, and it's got a metal in it. So this one's just kind of weird all around. So I think we just have to say, okay, that guy's really eccentric, and we just have to remember that that's how it is. I can't think of any of the others, well, unless you consider hydrogen sulfate and sulfate. But that has an H on it, and it has the word hydrogen. So, good question. Let's do some examples. Okay, so let's start with something easy. NaCl. Always ask yourself, what kind of a compound is this? You look at the first element. It's a metal. So this is ionic. Then you find that metal in the periodic table. What group is it in? Sodium is in group 1. Group 1, 2, 3, zinc and silver, no Roman numeral. So I write the name of the ion. The cation is just its element name. And then there's chlorine, all by itself, not with oxygen. So then the ending's going to be "ide." Okay? Sodium chloride. No prefixes. Nothing fancy there. How about PbO? Again, we look at the first element and we see it's a metal. What group is it in? Is it 1, 2, 3, zinc or silver? No. We don't actually have to say, oh, well, that's in group 4A. I mean, that's nice, but you don't need to know that. You need to know it's not in 1, 2, 3, zinc or silver. So that means this needs a Roman numeral. So I'm going to write its name, lead, and I'm going to leave a space inside the parentheses, and then I'm going to go finish off the rest of the name. Oxygen becomes oxide because it's a nonmetal all by itself as an ion. Now, with these Roman numeral ones, we can't tell the charge from the periodic table. That's why we need the Roman numeral. You have to figure it out from the formula, and specifically from the anion. So we look, let's write this down. Oxygen, we have to count -1 to fluorine, -2 to oxygen. So oxide has a 2- charge. We have one of them. Over here, we have one lead ion. These two together have charges that add up to 0. All compounds are neutral electrically. So if the oxygen's 2-, then the lead must be 2+. And so then we put the Roman numeral 2. The Roman numeral is not how many atoms of lead are in the formula. Okay, it's not lead 1 because there's one lead atom ion in the formula. It's the charge on that ion. Any questions about that one? Let's do one that's a little more complicated. Fe2O3. So we look at this and we see iron. Iron is a metal. I'm going to write its name, iron. And then we find it in the periodic table. We see it's not in group 1, 2, 3, zinc or silver. That means it needs a Roman numeral. So I'm going to put the parentheses in there, And I'll figure out what its Roman numeral is in a few minutes or seconds. And then oxygen is oxide. Now we go over here, and we know that oxygen takes a -2 charge. There are 3 oxide ions in this formula, right? O3. There's 3 of those. Altogether, what's the negative charge from them? It's -6, right? If there's -6 from all those oxides, then over here we must have +6, so they add up to 0. How many iron atoms are in there? There's 2. Fe, Fe. There's 2 of them. So between those 2 iron ions, they must have a total of +6 charge. I need to take that +6 and divide it equally between those 2. Okay, the concept here is challenging for people of all this messing around with charges and pluses and minuses and stuff. Once you get your mind around it, it becomes very simple. But until you get your mind around it, it's not so simple. So if you're not getting this, please keep asking me, okay? And I'll draw you pictures on the board. I drew somebody pictures earlier, and she was like, oh, okay, that makes sense. We've got this +6, we have Fe2, we've got to divide that up, so if we give 3+ to each of these, then we get a +6 charge. That's how we figure out the charge on that one. And so this is iron 3 oxide. Okay, any questions? I'm going to run out of time to do the acids. Let's do one example going the other way. Let's do, calcium nitrate. Oh, that just doesn't look very good. Calcium nitrate, and we're going to write the formula. Writing the formula, you really have to write the formula for each ion first. And on your worksheets we did in lab on Wednesday, a lot of people were not doing that. You're going to get lost and get the answer wrong if you don't do that. So calcium, well, the element symbol is Ca. We look at the periodic table. There's no Roman numeral. If there was a Roman numeral, that would tell us the charge. But we look on the periodic table, it's in group 2, so we've got 2+. Nitrate, you memorize. Until you have it memorized, look it up. But for the exam, you need to have it memorized. NO3, the -1 charge. Okay, we look at those charges. +2, -1, they're not the same. And so you can do that crisscross thing. And so the unwritten 1 becomes the subscript for the calcium. And that's really messy. And the 2 becomes a subscript for the nitrate. Nitrate is a polyatomic ion. When you have more than one of them, you have to put parentheses, like shrink wrap, around them so that we can see that, oh, this is a polyatomic ion. Any questions? I'm going to go on and talk about acids real quick here. We have 2 kinds of acids. Binary acids. Pretty much 2 elements. There's one exception. I won't do that to you on an exam, but I did it to you in the lab. So these are things like HCl and H2S. Hydrogen and one other element. And these have the formula for their name is hydro, and then the base of the nonmetal's name there, ic acid. So HCl is hydrochloric acid. And that one guy that shows up in the lab worksheet, HCN. You're like, well, that's not binary. Well, it's hydrogen and one ion. This is just kind of an exception, and it ends up being an exception because of the way your book defined binary acid. But this is hydrocyanic acid. So Cn minus is cyanide. So we change this ending to ic and put hydro in front, hydrocyanic acid. And then there's those oxyacids. And I wish I had left more time for this, but so something like HNO3, we look at the anion. That's nitrate. We're going to change the 8 to ic, nitric acid. If we have something like H2SO3, well, sulfate is SO4. This is sulfite. SO3, 2 minus, is sulfite. And so we change this to sulfurous acid. Going the other way, let's look at sulfuric acid. You see this ic, that tells you this came from 8. So this has the oxyanion sulfate. So write the formula for sulfate. The charge on the anion tells you how many hydrogens you need. Because what these acids are is they've got H plus. So H plus and 2 minus, to put those together, you're going to need 2 hydrogens. So I kind of skimped you on the end there, but hopefully that'll help.